seagrass meadows are the most productive and valuable ecosystem on the earth. The meadows form in shallow coastal water and they have diverse range of 60 species that live across. They support the ecosystem by providing a habitat need, perfect combination of water quality, and the importance of food sources for marine herbivores, from marine reptiles to mammals to invertebrates. However, 90% of them have disappeared due to the climate change and the pollution.
Seagrass restoration is widely spread among scientists across the world. It can be expensive and not always environmentally friendly. We found the opportunity to redesign the seagrass restoration anchoring system. Currently, most anchoring systems rely upon using steel, plastic, and bamboo. All these materials create pollution, waste, or have durability issues in the marine environment. Especially in Tasmania, it's very hard for seagrass to develop their root in a cold weather condition.
So our design concept developed into the biodegradable U-shape inspired by the acid stable. The structure is designed to support a young seagrass while growing a foundation within the sediment. The duration we arm for around 4 weeks and the ability to drill through the sandy seafloor where the seagrass will be planted.
For our bio material, it's sea urchin. Tasmania likely produce hundreds of tons of sea urchin waste every year. We collected them from Salty Row Farm. It mainly contain calcium carbonate, which will provide solid texture and strength to our equipment.
So we create the mold based on a U-shape 3D printer model to test the scale and the thickness.
It is our experimenting recipe. We add gelatin in water. Heat it up until 60 degrees. Then we add agar powder. And then we stir and heat up around 80 degrees. Then sea urchin in while the sample is hot. Mix until it's fine. Then our cross linking is borax. And glycerol oil. And we suck with syringe and put it in the mold. During this process, I keep monitoring for checking its shape and the thickness. This is our outcome. The material slightly reduced size because of dehydration. This is our recipe experimenting. It can last long more than 4 weeks. In salt water, we use pH tasting paper strip to ensure that even the staple is not decomposable, but it's not harming the environment.
Finally, based on our journal, the positive aspect of this biomaterial is friendly to the marine ecosystem, and we succeed in making the stable reach the durability arm. On the another hand, the same need to practical testing, then the monitoring in the longest term is around 2 months, and the 3D mold need to be thicker because it has become very fly after dryer. This method still requires hand planting, which might be a challenge for larger area. Once the material is wet, it cannot maintain its strength. That means it can be used in shallow water, or the driver cannot carry multiple at once.
Ultimately, this project demonstrates that we might find an alternative material for seagrass restoration and cleaning equipment. Although this is prototype, we believe our bio-design product offers a meaningful improvement to seagrass restoration by naturally stabilizing young seagrass in an environmentally responsible way.